So, given an n by n binary matrix image, flip the image horizontally, then invert it, and return the resulting image. To flip an image horizontally means that each row of the image is reversed. For example, flipping 110 horizontally results in 011, and to invert an image means that each 0 is replaced by 1 and each 1 is replaced by 0. So inverting 011 results in 100. That's pretty straightforward. All we have to do is flip it, then invert it, and then return the image. So we can create an output array, and then we can do for row in image, we can reverse the row. So row dot reverse. Now that we've reversed it, we can then invert it. So inverted, we can create an inverted array, and then for r in row, or for item in row rather, item in row, if item is equal to 0, then we add 1 to inverted because we flip the 0 and the 1s. So inverted dot append 1, 1, and then if it's not a 0, then we just add to inverted a 0. So if it's equal to 1, then we add a 0. And then we add to output, we add inverted to output. So append inverted, and then we just return output. Okay, cool. So this is how this worked. We defined our output array, and then we iterated over each subarray in the array image, and we reversed the array. So 110 became 011. We created an array inverted to store our inverted values. And then for each item in the row, so for 0, for whatever, for 1, if it's equal to 0, then we invert it, we add it to 1. So 1 is not equal to 0, so we know that we need to invert it using 0. So we added 0 to invert it, and then we continue down the line. So 1 is not equal to 0, so we add 0 to inverted, and 0 is equal to 0, so we add 1 to inverted. Then we added inverted to output, and we move on to the next subarray.